Hello, sixth graders. So we are going to continue topic 13. While we were still in school, we only did the first lesson of topic 13, which was area of parallelograms. So really quick, I'm just going to go over that first lesson just to kind of refresh your memories a little bit. So first I talked about the area of a rectangle. And we said that the area of a rectangle is length times width. The length times the width. And then we discovered that if we took a piece of a parallelogram and cut off this part and moved it to the end, we would get a rectangle. All right? And again, a parallelogram is basically any shape that has both sides parallel to each other. So these sides are parallel, these sides are parallel, okay? But this is the area formula for a rectangle, but the area formula for a parallelogram is a little different. We don't call this the length. Do you remember what we call it? We call this the base. We don't call, now we never look at the diagonal. That diagonal is misleading. That doesn't give us any information. Just like a rectangle, we always look at this vertical, all right? Do you remember, this isn't called a width either. Do you remember what this is called? This is called the height. So the area of a parallelogram is base times height. That's it, all right? So you should remember that from when we did that lesson a couple weeks ago, but all you need to know for this lesson is an area of a parallelogram is base times height, all right? So now that we remember that the area of a parallelogram is base times height, let's go over a few examples. So if I give you that the base of this shape is, let's say, 8 centimeters, and the diagonal is 4 centimeters, and then the height is 3 centimeters. Which dimension are we not going to use? So we're not going to use that diagonal. We don't need that diagonal. All we need to find the area of this is the base and the height. So the area of this parallelogram then is 8 times 3. So the area would be 8 times 3, which would be 24 centimeters. And remember, since we're finding area, you're either saying square centimeters or centimeters squared. All right, so let's look at this parallelogram. If we know how to find the area of a parallelogram, we definitely know how to find the area of a triangle. So let's go over a little example. So this is a parallelogram again. All right, now from this parallelogram, okay, we can find 2 triangles. So right now what I want you guys to do is to try to imagine how you can split up this parallelogram into 2 triangles. So what do you think you can do? So what I see is that I could split this parallelogram into 2 triangles by splitting it like that. Or you might have thought the other way, this way. Either way, you still get 2 triangles, okay? So we know that the area of a parallelogram, so area of a parallelogram equals area equals base times height, or area equals BH. So if this is a parallelogram and we can get 2 triangles from it, how do you think we use this area formula just to find the area of one of the triangles? So the area of a triangle, I'm going to repeat exactly what I just said. So the area of a parallelogram is base times height. And we see from this parallelogram, we can get 2 triangles. but we just want to find the area of one triangle. So what do you think you can do to find the area of one of these triangles? Well, if the whole thing is base times height, wouldn't one of those triangles be base times height divided by 2? And that's what it is. The area of a triangle, any type of triangle, you find the base, you find the height, and then you divide it by 2. All right, and that is the new formula that we're talking about today. So any triangle anywhere, you take the base, you take the vertical height, never diagonal, and then you divide both of those things by 2. All right, so let's go over a little example. Now, I like teaching that the area of triangles is base times height divided by 2, but you'll also see the area formula for triangles written like this, or area equals half base times height. Both of these formulas are equivalent. So if you see this, don't get freaked out that you don't know what it is. This is exactly the same as this formula. Because remember, multiplying by half is the same thing as dividing by 2. Personally, I like this formula better. It's just easier for me to understand. All right, so let's go over a few examples. Let's see, if I have a triangle that looks like this. Now, this is a right triangle. All right, so I'm given that the base, which is this, the base is 4 centimeters and the height is 5 centimeters. So with that information, I could set up my equation. Area equals the base, which is 4, the height times the height, which is 5, divided by 2. So 4 times 5 is 20. 20 divided by 2. The area of this triangle, area equals 10 centimeters squared. And that's it. That's all it is. All right. So you may see triangles like this, but you also may see triangles that look like this. Not right triangles, but triangles like this. You may see like an isosceles triangle. All right. In this case, the base, let's say, is 10 feet. Now, you don't know the height. They may give you the height like this. So they may say the height's like that, or they may just draw a straight line like that and tell you the height. Whenever you see this box, that tells you it's a right angle, and that tells you that it's exactly vertical, which would mean that it is the height, okay? So they may show the height like this or like this. Either way, it's exactly the same. Let's say they say the height is 5 feet. Okay, they may say 5 feet over here. So again, area of a triangle is base times height divided by 2. So area equals the base, which is 10, times the height, which is 5, divided by 2. Okay, so 10 times 5 is 50. 50 divided by 2. The area of this specific triangle is 25 feet squared. All right, and that's all we're going over today, that the area of a triangle is just half of what a parallelogram is. And I always thought that was really interesting.